Hello, everybody. So in this video, we'll go over those problems in practice test number 2 for Math 211, Calculus 1. Let's get started. Chapter 3 is all about differentiation, differentiation formulas, and derivatives. All right, let's go. All right, number 1. That's pretty easy, right? All you have to do is to apply the power rule. So f prime is 7x to the 6th power plus 6x squared minus 6. And what happens to the positive 1? Well, the constant terms go away. So that's it. Very simple. All right, let's go to number 2. All right, so when you have a square root of something inside, it's probably easier to apply the power rule if you just take it to the, change it to the another expression where the exponent is rational. So a square root becomes, of course, the 1/2 power. And so f prime is going to be 1/2 times what's inside. And then the new exponent will be 1 less than a half, which is negative 1/2, right? And this is a situation where f is a composition, so you have to use the chain rule, of course, right? So you have to multiply this whole thing by the derivative of the inside function. That will be 2x. And notice here, I do not want you to leave it like this. When you have 2 and 2 cancel each other, when you put 2 and 2, the 2 and 2 together. And then you do want to slide back, and you want to write this in a simplified form. The top is x, and that's the only thing you have. The denominator can be written again with a radical, right? Square root of x squared plus 3. So that it should be your simplified answer. All right, let's now go to number 3. Okay, for number 3, you also want to write the 5th power of x as x to the 1/5 power, and then apply the generalized power rule. So the exponent becomes the new coefficient, 1/5, and then x, the new power, new exponent will be 1 less than 1/5, so that's negative 4/5. And typically, we want to write an expression with a negative exponent in the denominator. So this will be 1 over 5 times x to the 4/5. You could also, you don't have to, but you could also write this as 1 over 5 times x to the 4th, and then the 5th root of it. Okay, so that's another way of writing that. Either one would be acceptable. All right, and then the next one. Oh, by the way, this could also be written as, this is x to the 5th power. I'm sorry, oops. This, you can write this as the, here you go, the 5th root of x raised to the 4th power. All right, that's going to give you an equivalent statement, so that's okay. All right, number 4, you can rewrite this as negative x to the -1 plus x to the -4, because that's, again, the same function. When you take the derivative, you apply the power rule twice. Okay, negative times -1 is +1. You don't even have to write it. The new exponent is -2 plus now -4 times the x to the new power, which is 1 less than -4. That's -5. All right, so you can rewrite this. I mean, you can write this as x to the -2 minus 4x to the -5. That is perfectly acceptable. You could also write this as a, let's see, 1 over x squared minus 4 over x to the 5th. Again, either one of these would be okay. All right, number 5. We move on to trigonometric functions. F is cosine of 3x plus pi. So f prime is negative sine. Remember, the cosine becomes negative sine of the blob. Okay. And then you multiply this by the derivative of the inside function. What am I talking about? The chain rule, of course. Now, the the derivative of the inside function is simply just 3, okay? Because it's 3x plus a constant, right? So you can rewrite this. Typically, we write the coefficient at the front. So it's -3 times sine of 3x plus pi. -3 times the sine of 3x plus pi. No problem, right? You can go through these rather fast, I believe. Number 6, tangent of x squared. Now, this is not the same as tangent of x squared, right? It's tangent of x squared. So first, we take the derivative of the tangent function, that's secant x of whatever is inside. And then you multiply this according to the chain rule by the derivative of the inside function, which is, of course, 2x. So the answer is 2x secant square of x squared. Now, again, that's one way to write that. If you want to, you can rewrite this as 2x over cosine squared of x squared. So either one would be okay. Again, it does not matter. Number 7, f of x is secant of pi x. So what is the derivative of secant? And that is secant tangent. And that's a product of secant and tangent. The argument for each is, of course, the blob. And now you take the derivative of that expression inside the parentheses, and that's pi, right? Now, again, that's okay, but I prefer to have pi in front since it's a constant. It's pi times sine of pi x, pi times the secant of pi x times the tangent of pi x, and that does the job, okay? All right, so in most of these cases, all you are doing is really applying your differentiation formulas, right? I don't think you'll have a hard time with this. Let's do one more, and then we'll go into the next portion of the video. Number 8, also trigonometric function, but this is an inverse trigonometric function. Sine inverse sine of x. Oh, sorry, inverse sine of 2 theta. So the derivative of the inverse sine, if you remember, is 1 over the square root of 1 minus the quantity squared. All right, so that's going to be 2 theta. That's the argument of the sine function, and you square that, right? And so is that it? Well, no, because you have the derivative of the inside that you still have to multiply this by. The derivative of the inside function 2 theta is, of course, 2, right? So this can be written as 2 all over the square root of 1 minus. Now you can keep the quantity 2 theta squared, or you can just multiply this out and write 4 theta squared. Okay, so that's how you do 1 through 8. All right, let's go to the next video clip to go to number 9, since we have talked about 8 problems already.